How to build a machine learning model in 7 steps. Building a machine learning model is a multi-step process involving data collection and preparation, training, evaluation, and ongoing iteration. Follow these steps to get started. Even for those with experience in machine learning, building an AI model can be complex, requiring diligence, experimentation, and creativity. But at a high level, the process of designing, deploying, and managing a machine learning model typically follows a general pattern. By learning about and following these steps, you'll develop a better understanding of the model building process and best practices for guiding your project. The right approach starts with identifying data needs and results in a reliable, maintainable final model. In between, you'll work through the stages of data discovery and cleaning, followed by model training, building, and iteration. Step 1. Understand the business problem and define success criteria. The first phase of any machine learning project is developing an understanding of the business requirements. You need to know what problem you're trying to solve before attempting to solve it. To start, work with the project owner to establish the project's objectives and requirements. The goal is to convert this knowledge into a suitable problem definition for the machine learning project and devise a preliminary plan to achieve the project's objectives. These goals should relate to the business objectives, not just machine learning. Although you can include typical machine learning metrics such as precision, accuracy, recall, and mean squared error, it's essential to prioritize specific business-relevant KPIs. Step 2. Understand and identify data needs. After establishing the business case for your machine learning project, the next step is to determine what data is necessary to build the model. Machine learning models generalize from their training data, applying the knowledge acquired in the training process to new data to make predictions. A lack of data will prevent you from building the model, but access to data alone isn't enough. Useful data must be clean, relevant, and well-structured. To identify your data needs and determine whether the data is in proper shape for model ingestion, focus on data identification, initial collection, requirements, quality identification, insights, and aspects worth further investigation. In addition, determine whether you will train the model once, in iterations with versions deployed periodically or in real time. Real-time training imposes many requirements on data that might not be feasible for some setups. Finally, during this phase of the AI project, it's important to determine whether any differences exist between real-world and training data or between test and training data. If so, decide what approach you will take to validate and evaluate the model's performance. Step 3. Collect, clean, and prepare the data for model training. After identifying the appropriate data, the next step is to shape that data so that it can be used to train the model. Data preparation tasks include data collection, cleansing, aggregation, augmentation, labeling, normalization, and transformation, as well as any other activities for structured, unstructured, and semi-structured data. Data preparation and cleansing tasks can take a substantial amount of time, but because machine learning models are so dependent on data, it's well worth the effort. Steps you might undertake during data preparation, collection, and cleansing include the following. Collect data from various sources. Standardize data formats and normalize data across different sources. Replace incorrect or missing data. Enhance and augment data, possibly by using third-party data or multiplying image-based data sets if the core data set is insufficient for training. Add dimensions with precalculated amounts and aggregate information as needed. Remove extraneous and redundant information, a process known as deduplication, and remove irrelevant data. Reduce noise and remove ambiguity. Consider anonymizing personal or otherwise sensitive data. Sample data from large data sets. Select features that identify the most important dimensions and, if necessary, reduce dimensions using a variety of techniques. Split data into training, test, and validation sets. Diagram visualizing the stages of data pipelines for machine learning, including both training and inference pipelines. Training and inference pipelines ensure data scientists and engineers can continuously develop and update machine learning models. Step 4. Determine the model's features and train it. Once the data is in usable shape and you know the problem you're trying to solve, it's time to train the model to learn from the quality data by applying a range of techniques and algorithms. This phase requires selecting and applying model techniques and algorithms, setting and adjusting hyperparameters, training and validating the model, developing and testing ensemble models, if needed, and optimizing the model. To accomplish all that, this stage often includes the following actions. Select the right algorithm for your learning objective and data requirements. For example, linear regression is a popular option for mapping correlations between two variables in a data set. Configure and tune hyperparameters for optimal performance and determine a method of iteration, such as learning rate, to attain the best hyperparameters. Identify features that provide the best results. Determine whether model explainability or interpretability is required. Develop ensemble models for improved performance. Compare the performance of different model versions. Identify requirements for the model's operation and deployment. Evaluate the resulting model to determine whether it meets the business and operational requirements. Chart listing types of machine learning algorithms, divided into supervised learning, unsupervised learning, and reinforcement learning. Machine learning algorithms are formulas or instructions that enable models to improve over time by learning from experience. Different algorithms perform better than others depending on the task at hand. Step 5. Evaluate the model's performance and establish benchmarks. Evaluating a model's performance encompasses confusion and evaluating a model's matrix calculations, business KPIs, machine learning metrics, model quality measurements, and a final determination of whether the model can meet the established business goals. During the model evaluation process, perform the following assessments. 1. Evaluate the model using a validation dataset. 2. Determine confusion matrix values for classification problems. 3. Identify methods for k-fold cross-validation, if using that approach. 4. Further tune hyperparameters for optimal performance. 5. Compare the machine learning model to the baseline model or heuristic. 6. Consider model evaluation to be the quality assurance of machine learning. Adequately evaluating model performance against metrics and requirements helps you understand how the model will work in the real world. Graph visualizing the bias-variance trade-off of machine learning models, comparing the precision and accuracy of high versus low bias and variance. Understanding the concepts of bias and variance helps developers find the sweet spot for optimizing a machine learning model's performance. Step 6. Deploy the model and monitor its performance in production. When you're confident that the machine learning model can work in the real world, it's time to see how it actually operates. This process, known as operationalizing the model, includes the following steps. 1. Deploy the model with a means of continually measuring and monitoring its performance. Develop a baseline or benchmark against which you can measure future iterations of the model. Continuously iterate on different aspects of the model to improve overall performance. Operationalization considerations include model versioning, iteration, deployment, monitoring, and staging in development and production environments. Model operationalization might include deployment scenarios in a cloud environment, at the edge, in an on-premises or closed environment, or within a closed, controlled group. Depending on the requirements, model operationalization can range from generating a report to a more complex, multi-endpoint deployment. Model iteration cycle, which includes business understanding, data prep, model training, inference and optimization, and model evaluation. Successful AI projects require iteration to ensure models continue to provide valuable, reliable, and desirable results in the real world. Step 7. Iterate and adjust the model in production. It's often said that the formula for success when implementing technologies is to start small, think big, and iterate often.